for today's lecture, we will learn how to make the integral for cotan function when we have odd or even power. As you can see here, regardless if the power was even or odd, the integration is usually solved using the substitution method. And because we will use the same concept and idea that we learned from the previous lecture for the integral for tan with odd and even power, we will use the same concept and same idea with the function cotan. We need to remember this formula. It is important. Cosec square, it will be equal cotan square plus 1. This important formula because it will help us to solve the integral with cotan function. Let's take some practical example. We have this question. Find the integral of the following function. We have the integral for cotan to the power 3x dx. As we notice, if the power is odd or even, we will solve the integral for this type of function by using the substitution method. If we have odd power, we will withdraw 1 to get the quadratic exponent. If 3 we withdraw 1, it will become 2. So the integral, it will become integral cotan to the power 2 x multiply cotan x dx. Then from the equation cosec square equal cotan square plus 1, we will get cotan. We will get this equation. Cotan squared will be equal cosec square minus 1. And then we will substitute this value in the integral. After substituting this value in the integral, we will get this result. And we will open the bracket, we will get this value. And after distributing the integral to the function, and we will call this equation number 1. Now we will try to solve the integral for each function alone. We'll start with this function, cotan x multiply cosec square x dx. We will use it by substitution method. We will take this part for our assumption. Here it will be equal cotan x, and after taking the derivative for our assumption, we will get du equal minus cosec square x dx. And we will multiply by negative sign to get this value. So cosec square x dx, it will be this part. And as we learn from to solve the integral by substitution method, we will put all the integral in term of u, and we will get this result. And how we will find the integral for this function? It is simple and easy. We just increase 1 in the exponent and we will divide it to the new exponent. The last step, we will put the integral in term of x. And finally, we will get this is the final result for this integral. And we will call it equation number 2. We already find the integral for this function. We need to find the integral for this function. So the integral for cotan x dx, it will be equal then sin x, and we will call it equation number 3. The last step, from equation number 2 and 3, we will substitute the result of this integral and we will put it in the equation number 1. And finally, we will get the final result for this integral. Let's see another example. Find the integral of the following function. Integral cotan square x dx. How we will solve it? In this equation, we have square, the quadratic exponent. So we will go directly to use the formula to simplify the function. We have cotan, then it will be cotan square equal cosec square minus 1. And we will substitute this value in the integral. And we will get this result. By distributing the integral to the function, the integral will become integral cosec square x dx minus integral 1 dx. The integral for cosec square, it will be minus cotan x, and the integral for 1 dx, it will be x, plus the constant number. Simple and easy. Let's see another example. Find the integral of the following function, integral cotan x dx. How we will solve it? Here we have the power is 1, so it will be impossible to get the quadratic exponent. What we will do, we will use the simplification by another way. We will try to simplify the function by another way. We have cotan, the integral it will be equal, integral cotan it will be equal cosine divided by sine. And we will use the substitution method to solve this integral. We will take sine for our assumption. So u, it will be equal sin x, and after taking the derivative for both sides, The derivative for u it will be du, and the derivative for sine it will be cosine x dx. Notice cosine x dx it will be this part. We will put the integral in terms of u, we will get this result. Integral 1 divided by u du. As this is the integral for this type of function, it will be ln u, as we learned from our previous lectures. The last step, we will put the integral in terms of x, it will be ln sine x plus the constant number. This is for today's lecture. I hope it is clear and see you next time.